Hello, students. All right, so this is lesson 8. This is the end of the lessons for the functions unit. So it's going to be a review plus learning how to do volume. Volume's pretty easy, so we'll worry about that last. So what you're going to learn is basically recognizing linear and nonlinear functions from graph equations and descriptions. And you just need to understand individual points in a graph and a table. So here's a graph of a proportional relationship. You know it's proportional because it's a straight line going through the origin. Notice the slope is up 2 over 3. That's also the unit rate in a proportional relationship because for every point you go up 2 and over 3 to get to the next point. The equation is y equals 2/3 x. 2/3 again is the slope or the unit rate. The table always goes through 0 and goes up by 2/3. If you divide the y by the x, so 2 divided by 3 in this case, you would get 2/3. 4/3 divided by 2 would be 2/3. 2/3 divided by 1 is 2/3. The only exception, of course, is 0 by 0. And the description would be something like, Jamarian walked at a constant pace of 2 miles every 3 hours if y is the distance and x is the number of hours he walked. The word constant or something like that will always be in there. So you know it's at a constant rate that they're going, which is required to be linear, because if it's not constant, it's not linear. Very related to the proportional relationship is the linear relationship. And so the only real difference on the graph is that it starts somewhere on the y-axis that is not through the origin. Okay, so again, from point to point, we go up 2 and over 1, and then we have the y-intercept here is 3, which is in the equation. So actually, proportional relationship would be y equals 2/3 plus 0, and when we're adding 0, we just drop it off. In this equation, this is the slope-intercept form of the equation. So the slope is the 2, and the intercept is 3. And we call that m and b. The equation is y equals 2x plus 3. Slope is 2, intercept is 3. The table, here's our intercept again, 0 and 3. So x is 0, y is 3. And then if you notice, it's always going up by 2 here. So it's always going up by the slope. However, if the x's are not going up by 1s, then what you have to use is the slope formula and subtract 1 point from the other point. If they tell you it's linear, you only have to pick 2 points and subtract. If they say determine if it's linear, you have to check all of the points. So if I did 7 minus 5 over 2 minus 1, I would get the 2 over 1. And it works if I skip points. So if I down here, 3 minus 3, or sorry, 9 minus 3 is 6, and then 3 minus 0 is 3. So I have an equation of 6 over 3, and that reduces again to 2. So it doesn't matter which 2 points you choose. You will always, if you subtract the y's over the x's, you will always get the slope. The word description would be something like Clara started with 3 apples and bought 2 juice boxes every hour. X is the total items, Y is the juice boxes. So we start with the intercept and we go up by the slope. Now we're getting to nonlinear. This is a proportional relationship. Obviously in a graph, it's not straight. These don't always have to go through 0, but I put all of them through 0. Okay. Looking at the table, if these are going up by 1, notice the difference here. Here I'm subtracting 3, subtracting 1, adding 3, so it's different every time. And if I pick 2 points and subtract the y and the x's, we'll get something different. So like 1 minus 0 is 1, 1 minus 0 is 1, so that would be a slope of 1. Here, I have 0 minus 1 is negative 1, and 0 minus a negative 1 is positive 1. So that slope would be a -1. And you can see that in the graph. Here, between A and C is a +1. And here, between A and B is a -1. Okay. Y equals x to the power of 2. So nonlinear has a exponent that is not 1 or 0. So in the equation, it's really easy. Find an x term. If you see a number up here, it's not linear. The description would be something along the lines of the area of a square is always the square of the lengths of the sides. So we're always doing the square of a number. And you always have to have a y, define your y, and define your x. In this case, y is the area of the square, and x is the length of the sides. All right. This one is, again, very similar to a parabola, except this is y equals x to the power of 4. So when you have even exponents, it'll make a U shape, and exponent y equals 4 means y is x times x times x times x. And again, you can see the y values change how much. All right. The odd numbers, when it's y equals x to the power of 3, we get this S shape. Okay. And again, in the table, the numbers change by a different amount every time. The equation, y equals x to the power of 3. So volume of a cube is an example of this equation. And basically the y is x times x times x. You don't really have to memorize all of this. You just have to know if you have an exponent that is basically a number in any of the terms, then it's going to be nonlinear. Okay. So x to the 5th looks exactly the same. The numbers are just going up dramatically bigger. Y equals x times x times x times x times x. Right? The last two are different, but the same. This is an exponential equation. It goes up really fast, but it never actually touches the y-axis down here. And it's looking in the form of 2 to the power of x or 3 to the power of x. And again, our exponent is not 1 or 0, or we just have an exponent there. So we know it's not linear. We call this a geometric progression. And basically what happens is every time x changes, you multiply by 2. So if I have a -1 times -1, sorry, if I have 2 to the power of -1, that is like 1 over 2. If I have 2 to the power of -2, that's 1 over 2 squared, which is 1 over 4. So these numbers keep getting fractions closer and closer to 0. And then as I go up into the positive numbers, they get bigger. But our exponents of 0 is actually any number to the 0 power is 1. So our geometric progressions always start at 1, and then they double or triple or quadruple, depending on what number is in your base here. And the last one is the inverse equation. Again, nonlinear. And basically you've got two u's and they never go through the middle. Of course, you can shift these to the left or right. And basically it's 1 divided by your x. It's the reciprocal, which is our math way of saying 1 divided by a number. Can't be 0 because 1 divided by 0, you can't divide by 0. So that's why it never actually hits the middle of the graph. But we can see that the loops kind of repeat themselves. When they're negative, it's 1 over the negative number, and when they're positive, it's 1 over the positive numbers. So we have that negative loop on the bottom, or negative curve on the bottom, and the positive curve on the top, but never quite getting to 0. All right. So you need to find specific information from a table of a function, write the rule of a function table and equation with x and y, fill in the blank spots of a table. You need to know how to graph an equation, usually on Desmos or GeoGebra. You need to determine if a function is linear or nonlinear from the table. And then you need to compare these functions. Compare like a table to an equation or to a word description. And then we need to know the volume of a cylinder, cone, and a sphere. I recorded this and then I was like, oh, I need to put some volume in there just so you can see it. So we have a cone, a cylinder, and a sphere, and they all have formulas. And the formulas say volume, you do this to get volume. And the formulas have usually a radius and a height. They have some sort of thing that comes from your object that you're getting the volume from. And for a cone, it's pi times the radius squared times height divided by 3, or 1/3 of pi times radius squared times height, 1/3 of a cylinder. So pi is 3.14, and in this cone, we have 5 meters and 13 meters. So the radius is half of the circle at the bottom. Sometimes they'll give you the diameter, so make sure you're only getting half. And the height is always from the center straight up. It's at a right angle. They have to show that. So this height looks like this is 13. It's not. This is 13. When we get to 9th grade, you'll probably actually get this edge and this, and you'll have to figure out what this is, and you can do that with the Pythagorean theorem, which we did before. But that's beside the point. Here we have a 5 and a 13, so I do pi times 5 squared times 13 divided by 3. 5 squared is 25 times 13 divided by 3, 325 divided by 3. I put the pi on the other side, and this answer is fine. 325 over 3 times pi meters cubed, because its volume is cubed. Or you can multiply that 325 times 3.14 and then divide all that by 3, and that would be meters cubed. Okay, there's a calculator out there. You just Google cone calculator and you'll get this thing here. It'll have a little picture of a cone, and you put in the 5 and you put in the 13, and it shows you the work down here. See that H is a 13. When you put in the 5, the R changes to 5, and then it gives you the answer, 340.34 meters cubed. Notice we had 325 divided by 3 times 3.14. So when you multiply by 3 and then divide by 3, it's kind of like cancels it out. So it's basically 325 times 0.14, which gives you 340. Okay, make sure you use the correct radius and not the diameter. A sphere, same thing. Search for a sphere calculator, and it'll give you the sphere, and check your volume. Okay, and it's 4/3 pi r cubed. And actually, I did this one wrong now that I look at it, because this is the diameter. So my radius is going to be 21. So I did this wrong. So make sure you check for your radius and not your diameter. And it shows you the work is 3.1 times 10 to the 5th, which is 310,339 centimeters cubed. Okay. Volume, same thing, of a cylinder. Cylinder is the same as the height. It's pi r squared times h. Pi r squared, if you remember, is the area of the circle on the bottom, and then times the height. So you're just telling me how many circles it takes to stack up to make a cylinder. And a cone is 1/3 of a cylinder, so they're very related. So make sure you're using the radius, not the diameter like I did. Using the correct calculator that is going for volume, not surface area. Put in the numbers, show your work, and you're done. The way they test, if you really know this, is to give you weird options. So here we have a half of a sphere with a cylinder inside. So if you wanted to find just the part that is not the cylinder, you would have to find the volume of the sphere, find the volume of the cylinder, divide the sphere in half because it's half a sphere, and then take off the volume of the cylinder. And this one looks like it's even got the top missing, so you'd have to do something weird for that as well. So they can get really complicated on this stuff. But we're going to start pretty easy, just the volume of them, and then you might have one shape inside of another shape, and you'll have to subtract them. So that's it for volumes. They're really easy. Calculators are your friend, and have a good day.